welcome to Indices Academy. My name is Daniel and I'm glad you're watching me. And if you're new to this channel, on a weekly basis we shoot educational videos that will ease your journey as a student. So I encourage you to subscribe by clicking on the subscribe button down below. Also remember to click on the notification bell so that you will receive every notification whenever we release a new video. Without more being said, let's get to the ball so that we can get started. Thank you. Let's get started with today's class. In today's class, we're looking at formula breakdown in physics. And our agenda is to discuss the following subheadings: power, Young modulus, electric field intensity, Coulomb's law, electric potential, as well as momentum. So let's get started with power. What is power in physics? In physics, we define power as the rate at which work is being done. Alright? If, for instance, from point X to point Y, let's say we are to take a bucket of water from point X to point Y, and let's say, for instance, Mr. A takes the bucket of water from point X to point Y in 2 minutes. Alright? While Mr. B takes the bucket of water from point X to point Y in 3 minutes. Alright? In 3 minutes. Now, Mr. A is said to have more power than Mr. B because Mr. A does the work with a lesser time. Alright? With a lesser time complexity. With a lower time, alright? With a lesser time, because 2 is what? Less than 3. Alright? So mathematically speaking, we could say that our power is equal to what? Work done over what? Time taken. Alright? Now what is it? Let's call this equation 1. What is the formula for calculating work done in physics? Work done is what? Force times what? Distance. So our power can be equal to what? Force times what? Distance, S over what? Time. Alright? Now if we proceed further, we can write our power to be equal to what? Force times what? Distance over what? Time. Alright, the S represents distance, okay? Now, distance over time in physics represents what? It represents velocity. Therefore, we can write our power to be equal to what? Force times what? Velocity. We'll call this equation 2. Alright? So now, based on this equation, we could say that the formula for calculating power can also be written as what? Force times what? Velocity. What is the unit of measuring force? Force measured in what? Newtons. What is the unit of measuring velocity? Velocity is measured in what? Meter per second. Alright? Meter per second. So based on this formula, our derived unit for power will be what? Newton meter per second. Based on this formula. Okay? Now, if we still further want to break this formula down, our power, now watch, our power, which is equal to what? Force times velocity, can be seen as what's the unit of measuring force? So what's another formula for calculating force? Force is calculated as what? Mass times acceleration. So our power can be equal to what? Mass times acceleration times what? Velocity. Alright? Times what? Velocity. So even from here, you could replace force to be what? Mass times what? Acceleration. But I'm trying to explain this because Jamb is a very funny exam. They like tricking questions. So I'm trying to make sure I break the formula to all the parts that, even though they trick you, you'll be able to discern and know exactly which of the formula to use. Alright? So now, based on this formula, we could derive another unit for power as what? Mass measured in what? Kilograms. Alright? Acceleration measured in what? Meter per second square. Velocity is measured in what? Velocity is measured in what? Meter per second. Alright? So if we multiply this now, we'll have what? Power to be equal to what? kg. Now m times n will give us what? M square. Now, based on the law of indices, this one is raised to the power of 1 and this one is raised to the power of 1. That's what we're going to add. Alright? 1 plus 1, that is giving us 2. And m times n will also give us m squared. Now, based on the law of indices, minus 2 minus 1. Minus have more power than plus. So instead of adding now, we're going to what? We're going to add them. That will be minus 2 minus 1. Alright? Minus 2 minus 1 will give us what? Minus 3. So now, this underlying thing is another derived unit of power based on this breakdown. This one here is not the formula. It's just a derived unit of what? Of what? Power. This equation 1, 2, and we call this equation 3 are all possible formulas of power in a CBT exams like Jamb. Alright? Take note of that because this academy tries to make sure that you pass your Jamb this coming year. Alright? By showing you all the methodologies that Jamb want to use to trick you. Okay, before we proceed to Young modulus, I will need to explain some things. The SI unit, that is the standard unit of measuring power, is in watts. Alright? But based on the derivation of these three equations, where we brought out some other formulas, this is the derived unit for measuring power. Alright? This is the derived unit for measuring power based on what? Formula breakdown. Okay, this is the derived unit of measuring power. So please take note of that in your CBT exams, alright? In your OBJ exams, okay? So let's proceed now to Young modulus, okay? So permit me to just clean this part quickly. Let's proceed with what? Young modulus. Now, Young modulus is a term that explains the extent to which a material can be stretched or deformed. Alright? Mathematically speaking, Young modulus can be represented with what? Y or E. But in this case, let's represent it with Y. Young modulus Y is equal to what? Stress over strain. Alright? Now, our stress is equal to what? Force over what? Area. And our strain is equal to what? Extension over what? Length. Now, take note of this before I continue. Strain is a quantity in physics that do not have a unit of measurement because extension is measured in what? Meter. And the length measured in what? Meter. So both the meter and meter what? Cancel out. Alright? Therefore, if I put this thing out for stress, my Young modulus Y because what? Force over area divided by, because this is the stress, force over area divided by what? The extension, which is what? E over what? L. Divided by the strain, which is what? Extension over what? L. Now, if I introduce a multiplication inverse, my Young modulus becomes what? F over A times what? L over what? E. Therefore, my Young modulus equals what? FL over what? AE. Alright? So now, since L over E do not have a unit of measurement, because meter and meter will cancel, alright? What is the unit of measuring force? Force measured in what? Newtons, alright? And what's the unit of measuring area? That means my derived unit based on this formula, my Y will be equal to what? Newton over what? Meter squared. Because force is measured in what? Newtons. And area is measured in what? Meter squared. Therefore, my Y will be equal to what? Newton per meter squared. Based on this formula. Right? Based on this formula. Okay, because if I proceed further, I could break, let's call this equation 1. Based on equation 1, this is the derived unit of what? This is the unit for measuring Young modulus, alright? But if I further break this down, my Y can be equal to what? Mass times what? Acceleration times what? Length over what? Mass over what? A times what? The extension. Alright? I broke this down because force goes to what? Mass times what? Acceleration. Okay? So now, the unit of measuring, the derived unit for measuring Young modulus can be given as what? Mass measured in what? Kilograms. That becomes kg times what? Acceleration measured in what? Meter per second square. Alright, divided by what? Meter square. Now the extension will cancel out. Alright, so even for this, we can say Young modulus formula y can be equals to what? MAL over AE. You can call this equation 2. Alright, Young modulus formula can be written like this because CBT exams are so funny. They could want you to imagine imagine something to the extreme. Alright, so now this is meter square. So now this is division sign. So meter means what? Meter square means what? Meter times meter. So one of the meter here will cancel one of the meter here. So we left what? M is equal to what? Kg s to the power of minus 2 over m. Just a single m because here was meter square. Meter square means what? Meter times meter. So meter times meter, one of the meter will cancel one of this meter. Therefore, our derived unit for measuring Young modulus y will be equal to what? Kg L minus 1 S minus 2. So finally, this becomes the derived unit for measuring what? Young modulus. Remember, equation 1 we did formula breakdown. Alright, for this now, this is the derived unit for measuring Young modulus. Please, if there are any question to it, to drop it in the comment section. And before I continue, as we proceed further with electric field intensity, I want us to discuss Coulomb's law first of all. Alright, so there's a video, there's a description showing up here by the top hand corner of your screen. If you are yet to watch that video, you can go ahead and watch it, and I also put it in the description below. Alright, you can click on it and watch the full video. Okay, so now we said that Coulomb's law states that the electric force existing between 2 point charges Q1 and Q2 separated by a distance r is directly proportional to the product of the charges and inversely proportional to the square of the distance between their separation. We said mathematically our F varies as what? Q1 Q2 over r squared. Okay, where we introduce the constant of proportionality K, so that our F equals to what? K Q1 Q2 over r squared. And we say that the value for our K is equals to what? 1 over 4 pi to the E naught, where we say E naught is a permittivity of free space, a constant in physics as well. Alright, so if I introduce this into, okay, let's call this equation 1. Let's call this equation 1, okay? Now, if I would proceed further to talk about electric field intensity, electric field intensity is also known as what? Electric field intensity is also known as what? The strength of an electric field. Alright? It is defined as the force per unit charge in an electric field, okay? It is represented as what? E equal to what? Force over charge. Alright, now this force represents the electric force, which could either be a force of attraction or a force of what? Repulsion, depending on the nature of the charges in the electric field. If there are similar charges, then there will be a force of what? Repulsion. But if the charges are unlike, there will be a force of what? Attraction. Alright, so now if I introduce the value for F, which is equal to this in this equation, that means my E becomes what? Now instead of writing F, I'll write this value, which is what? K Q1 Q2 over r squared divided by what? Q. Alright? So now, if I turn this into a multiplication inverse, my E will be equal to what? K Q1 Q2 over r squared times what? 1 over Q. Alright? Now, one of this Q, we cancel one of this Q here. Alright? So that my E is now equals to what? K Q over what? R squared. I can call this, let's say I call this equation 2, I can call this equation 3. Alright? This is another formula for calculating what? The electric field intensity. Also known as what? The strength of an electric field. But remember, I said the value of K is equal to what? 1 over 4 pi to the E naught. So if I decide to introduce that value here, that means my E will be equal to what? Instead of writing K Q over what? R squared, my E will be equal to what? The value for K, which is what? 1 over 4 pi to the E naught times what? Q over what? R squared. Alright? So if I go ahead to multiply it, I have what? E is equals to what? Q over what? 4 pi to the E naught R squared. I'll call this equation, let me call this equation 4. Alright? So this is another formula. Alright, from the breakdown of formula, this is another formula that can be used to calculate the strength of an electric field, also known as what? The electric field intensity. And also remember that from equation 2, if we cross multiply this times this, that means our F can be equals to what? Our F can be equals to what? E times Q. Alright, that means another formula for calculating the electric force is equal to what? The electric field intensity times the charge. Are we together? So I can call this equation what? 5. Alright? So we have been able to prove down 5 equations from the two concepts, electric field and Coulomb's law. If there are any questions, hope to see them in the comment section. So we'll proceed to the next in line called the electric potential. As we proceed, the electric potential in physics is represented with the letter V. Alright? Now, it is defined as a work done in bringing a unit positive charge from infinity to a point against the electrical forces of that electric field. From infinity to a point means from an unknown point, alright? From any distance at all to a point as against the electric forces of that what? Of that field. Alright? So it has a relationship with what? The electric field intensity. And remember, we said that electric field intensity represented as what? E. Therefore, our E, electric field intensity, is equal to what? The electric potential divided by D, where D is the distance traveled from a point of infinity to the known point as against the electric forces in that electric field. Alright? So if I cross multiply this times this, that means my V equals what? Electric field intensity times D. Alright? And now remember, we said that, okay, now based on this, electric potential is measured in what? Volts. Alright? That means 1 volt. That means our volts equals what? Electric field intensity is measured in what? Newton per coulomb. And distance is measured in what? Meter times meter. So based on this now, our V, the unit of measuring our V is what? Newton meter per coulomb. The unit of measuring what? Our V. Alright? But based on equation 4, if I will proceed further to derive, to break down this formula, we say that our E is equal to what? Based on equation 4, our E is equal to what? Q over what? 4 pi to the E naught R squared. Where we said from equation 1, we say that R squared is the distance separating the what? The two charges. Alright? The 2-point charges in Coulomb's law. That means this my R, I can rewrite this equation as what? Q over what? 4 pi E naught D squared. Because the R represents distance. Distance of what? Separation. So if I bring this formula now to put it inside this one here, that means my V equals to what? Instead of writing the E now, I'll write this formula. Q over what? 4 pi to the E naught D squared times what? D. Alright? Now, D squared means D times D. That means one of the D will cancel one of the D here. That means my V, which is the electric potential, will finally be given as what? Q over what? 4 pi E naught D. Alright? So we can call this equation C. Okay, let's call this, let's say we call this equation 6, we call this equation 7, and we can call this equation 8. So electric field intensity, Coulomb's law, and electric potential are packaged together in one topic. That's the reason why I do not clean the whole board in order to explain the two of them. Alright? Thank you very much for staying with me to the very end of the class. I appreciate you. And please, if there are any questions, I would like you to put them down in the comment section because we'll attend to them one after the other. And I also like you to share this opportunity with your friends in school. Tell them the benefits you are getting from Indices Academy. Thank you very much and see you next week.